Hello, this is Robert Kelly, and I'll be sharing with you about the coefficient of determination. Coefficient of determination, also known as R squared, lets us know how useful is a correlation to making predictions. Let's say we're talking about IQ. If we are trying to guess someone's IQ and we don't know anything at all about that person, our best guess for IQ would probably be to predict the average IQ, or the mean IQ, which is 100. But if we happen to know something else about the person, which is correlated with IQ, we can take that into account. So let's say, for example, a crossword puzzle score along the x-axis here is correlated with IQ here on the y-axis, and that the correlation is 0.625. That's a good correlation. It's a moderate correlation. And here we can see on the scatter plot a best fitting line, our linear regression line, going through all those points. And this best fitting line helps to minimize the error between the line and all the points. And in fact, if we're going to make predictions of IQ, we could use this best fitting line so that we take into account crossword puzzle score and then predict IQ. Let's say that we know that Greg's crossword puzzle score is a 10. Now we could just ignore that and still guess his IQ is 100, or we could take it into account. If we take it into account, here's crossword puzzle score of 10. We go up to our best fitting line, then we go over to IQ, and our best prediction for Greg's IQ is 89. Note that if we predict an 89, there are some people who had a crossword puzzle score of 10 who had a higher IQ than 89, who had a lower IQ than 89. 89 is just going to be our best guess. So again, for Greg, we could predict an IQ of 100 and just totally ignore his crossword scores. Or our alternative is to predict an IQ of 89, knowing that it's still not going to be perfect. His IQ may be a little bit above or a little bit below, but it's going to help us. Now you might ask, why do we care about taking that crossword puzzle score and using it to predict IQ? Well, presumably, crossword puzzle score and IQ are influenced by similar things. That is one's brain processing abilities, one's educational and cultural opportunities and nutrition, whether you got a good night's sleep, with your testing conditions. All of these can influence IQ and crossword puzzle scores, as well as other things. How often one does crossword puzzles could influence crossword puzzle scores and so on. All we know is that correlation between IQ and crossword puzzle score is 0.62. And our coefficient of determination, R squared, is 0.391. That 0.391, that coefficient of determination, tells us what proportion of variability in IQ is accounted for, it's explained by knowing someone's crossword puzzle performance. So if we take their crossword puzzle performance into account and we then guess their IQ using that scatter plot, we're not going to be perfect in our predictions, but we're going to be a lot better than if we just guessed the mean of 100 every single time. So if we take into account crossword puzzle, there's still 61% of that variance that's unexplained, but our coefficient of determination, 39% of it is explained. That is, we reduce the error in our predictions by 39% when using the crossword puzzle scores to predict IQ. So let's return back to our two options. When guessing Greg's IQ, one thing we could do is simply guess the average IQ score. And there's going to be a fair amount of variability. Our variance will actually be 256. Or we can use a crossword puzzle score to predict the IQ. Fairly good correlation here. And if we do that, then we know that yes, we'll still be making some errors, but our errors will be less. By using the crossword puzzle score to predict IQ, notice that this distribution isn't as wide, there's not as much variability. Some 39% of the variability is already accounted for. This variability here, known as 1 minus R squared, this variability remaining here is the variability that was unaccounted for. So in conclusion, R squared is a variance that's explained. 1 minus R squared is a variance that is unexplained. If our correlation was R equals 1, 1 squared would be 1, and we would be accounting for the entire variance. All those dots would fall along the line. In this case, we've done a good job.